Well, welcome to the OKTurbo rocket shop. I'm actually inside right now, but what we're going to do here is I decided to make a dual deployment version of this Mighty Mick. Now over the years, I've built several of these upscale Mighty Micks. The original Mighty Mick was a 24 millimeter low power design from Thrustline Aerospace back in the day. And back in 05, I believe it was, I decided to do an upscale for my level 1. So I used lock tubes and put it together. There's nothing fancy about it. But since then that one's crashed. I rebuilt it. Then I ended up building a whole new one. But what I thought I'd do here is just kind of as an encouragement to people who may have not scratch built any of these rockets. I don't know if it's really that much cheaper than buying a kit, but it certainly is. You can get a design that nobody else has. You can kind of do your own thing. Like the graphics, that's always kind of been my thing, was the graphics. When John Rowan Stern had Thrustline Aerospace, I helped him on a couple of designs, just the graphics of it. He would send me a kit that was blank, and I would kind of figure out the graphics on it. There was a Starship Electra, there was the Mike 9, and then probably the one I'm most proud of is the Arapahoe E. And even that design still lives on today. It's sold by Squirrel Works, but the paint scheme that you see in the graphics is basically what I came up with, just trying to play homage to the old Cherokee D, but kind of make it a little bit different, but kind of in the same vein. I actually did a high power version that's a modernized version of the Arapahoe called the Arapahoe X. But anyhow, so I'm kind of diverging here. But what this is going to be is a series of videos where we go through step by step, and I can kind of show you how OKTurbo designs a rocket. So got some old pictures here. So here's like one of the original Mighty Micks. This was in Pawhuska at the Tulsa Rocketry launch. I was going for my level 1 on this one, but I thought I'd get fancy and use the chute release, and it got tangled up, didn't work right, flopped on the ground, did get my level 1. I ended up getting level 1, I don't know, a month or two later at Tulsa at one of the regular launches in Oklahoma, in Leonard, Oklahoma. But anyhow, so that's like the original one. I still got that one. It actually came down hard at the sport launch National Sport Launch in Alamosa, Colorado. Old pictures. It's funny to see pictures of the old shop before it became a giant mess. But like I said, this is like 17 years ago. Back in the day, now I've got a Cricut vinyl cutter. So back in the day, I cut this all out by hand. So I drew up the graphics, taped it down on some scrap vinyl, cut it out, and basically made a hand-cut vinyl mask to paint. So that's how the graphics were done back then. Here's another, like the Shamrock. I drew it out on paper, taped the paper down to the vinyl, cut it out, and use that as a mask to paint with. So that's what I did now. Now I've got a Cricut machine, and so this is kind of what this is. This is in the Cricut software, the vinyl cutting machine. So I've made some new graphics, and when we get to that point, you'll see that. But that's what that is. So give somebody a Cricut vinyl cutter and building rockets, and I get pretty dangerous. So there's a lot of that. So the other thing that I've done is I've used RockSim. So the thing in RockSim is, this is a proven design, but I scaled it up, kind of get the proportions right. It's using the Estes Maxi Dur-Red Max nose cone, which is basically the same as the Dur-Red Max on the old Mighty Mick. That same profile. It's kind of more of a rounded profile. It's not as pointy. They don't really have that well, I might be able to load it into RockSim, but they didn't have it. But the biggest thing here is to get a nose cone that's basically the same shape, put it together, get the proportions right, the dimensions right. You can do all kinds of stuff in RockSim, but the most important thing is this calculation of the center of pressure. And the center of pressure has to do with the geometry. You can put whatever you want to inside of it. You know, if you're using big motor mounts and bulkheads and eBays and things like that, that really affects the center of gravity. And the other way to really know that is once you've built the thing is to check the center of gravity. That's where it balances. The center of pressure has to do with the geometry, the size of the fins and how many there are and things like that. So that determines your stability. So you always want your center of gravity, you know, probably at least one body tube diameter, one caliber ahead of that. The rocket will always rotate about its center of pressure. Any free body in space rotates about its center of gravity. Kind of like you see guys, you know, tossing those juggling pins. You notice how they spin funny because they're spinning about the center of gravity. The center of pressure is where the external forces work. So to stabilize it, so you always want that center of gravity ahead of the center of pressure. If not, it's going to do the loop-de-loops, which you've probably seen on some of these videos. So when you're scratch building, you know, if you use a proven design, even if you upscale it, you know, that place where it is, it'll upscale with it. So it's that center of pressure will always be the same. So, and this is really just a simple 3-fin nose cone kind of rocket. What I'm doing this time is I'm going to put electronics bay in it and put an altimeter, and we're going to go dual deploy. It's going to have a 54 millimeter motor mount. So blah, blah, blah. What you can do in RockSim is you can print out the fin pattern, which really helps. So I've got that printed out. Next thing what we're going to do is we're going to go out to the shop, and I'm going to kind of go through, I've been putting together the quote unquote kit and kind of show you what that is. It's all lock tube and like the Maxi Dured Max 4-inch nose cone, which unfortunately right now they're not available. Months back I had bought 3 of them just because they were on the website, and I bought 3 of them. And the original one was actually turned by Gordon Agnello, Sandman. So back, you know, 17 years ago, he actually made me the first one, which is made out of balsa, and I covered it in fiberglass. But anyhow, kind of rambling, but let's get out to the shop and let's look at the parts to build the upscale Mighty Mick dual deploy. Here we are back out in the shop. So I just finished this one. This is the Mighty Mick I built to replace this one. This was the old original one. You can see it, I kind of sanded it back, but it got cracked. The body tube, the airframe got cracked when it hit a big old rock at Alamosa. And just a little tip here is if you're flying at higher altitudes, you need a bigger parachute because it kind of came down fast and hard. So the old one's busted. The nose cones, I mean, it's not terrible busted, but it's like, okay, I just need to rebuild it. But this is the old original nose cone that Gordon Agnello Sandman made. So it's balsa, and I covered it in some lightweight fiberglass, and so that's from 2005, I believe. So anyhow, so that's that old one. Here's the one I built to replace it. So it's just a motor eject, very simple, 38 millimeter motor mount. It's like a big model rocket. So you just set the delay on your motor to match, you know, what altitude you predicted. That's all done in RockSim. Like I showed you the model in RockSim. What you do is you can actually weigh it when you're done building it. Weigh it, override the mass calculation in RockSim. Put in the actual mass. It gives you the center of pressure. I think I've got it marked on here. Yeah, there it is. So there's the center of pressure marked. So now if I balance this, you know, once the motor's in it and the recovery gear's all in it, you can basically hold it and see where it balances. And it's right about in this area here where it's bouncing right now. So, you know, before you launch, you make sure you check your stability, make sure it's all okay. But this is the vinyl I cut for like a new updated Mighty Mick version 1, 38 millimeter. So that's what that means. Anyhow, so this is going to be the dual deploy 54 millimeter motor mount. I actually bought the parts from Lock Precision to do the, I think they call it the lock-in ring. So it's got centering rings for the fin can that holds the fin, keeps everything perpendicular. Plus you can put a motor mount adapter in here, so I can go down to 38 millimeter, even down to 29, but I don't think I'd ever go that small. H&I motors in 29 millimeter are very long. So it's going to be probably 38 millimeter or 54 millimeter motors. Here's the 54 millimeter motor mount tube. I bought two, we call them 4-inch tubes, but actually they're 3.9-inch cardboard lock body tubes. Here's the Estes 4-inch nose cone. For electronics, I'm just going to use an RRC3 altimeter. These things are, I've never had a problem with them. They work great. I've used the RRC2 and the RRC3s. They're just great altimeters. They're not too expensive. They work great. Very simple. I'm not doing anything too fancy with them, just sport flying. So these are the parts for the electronics bay that you get from Block. So this bigger, stiffer tube goes inside of that coupler. And then there's like a switch ring that goes around. You got all thread rods and things like that, and a sled to mount the electronics onto. So that's what all that is. That's for the electronics bay. Like I said, this is the lock and ring set that'll be in the fin can. I bought a couple of shot cords. These are just the lock. That's the thing about lock precision is, old school is not always bad. I mean, you can buy fancy Kevlars and things like that. I actually kind of like the nylon. It gives you a little more spring, I guess. Plus, it's not as expensive either. So, I mean, that's a bonus. Why make it too complicated? I will use shear pins. So I bought some extra little shear pins, screws from Lock. These are the graphics. Like I said, I was on the Cricut machine. I kind of updated the logo from the other Mighty Mick and added some white in here because there wasn't much contrast between the dark green and the black. So I think this will look better. These were all cut by me. I've got a black and a NAR logo, and I think this one's red. On that one, I put an orange one. But that's the thing about having your own Cricut machine is you can make your logos or your graphics however you want. Excuse me. So also there's my OKTurbo. I'll put that on there, and I'll probably end up putting since they're actually green, they'll probably go pretty good with the rocket. So those are all the graphics. That'll be when we're done painting it and stuff. So this is the layout of the parts. What you get out of RockSim is, you can tell I've already scribbled on it, and I'm already starting to change things up. I wanted to move the electronics bay a little further forward to give more room in this back end for the drogue chute and recovery harness. When I was looking at it, it's like there's not much room there with the motor tube and the back end of this electronics bay. So I kind of moved things forward. The overall length is still the same. It's just basically shifting things. So, once I got out here and started looking at it, I didn't go on the computer and redesign it, but it does give you, RockSim does give you a list of bill of materials. So it'll tell you, body tube, lock, precision, 3.9. Of course, there's where I scribbled it out. It was 18 inches. Now it's a 16-inch length. So 16-inch, 25-inch. The other good thing it does, it will give you the full-size fin pattern to cut it out. So, the printer's smaller than the fin, so it gives you two pieces, but you tape those together and then use those to outline it on your plywood. A few more scribbly things. There's that's the fin that I used on the other version, the old version. These are all going to be through the wall. So there's like the order form from Block. So you basically build your own kit. I've got aircraft ply, birch ply, a big box of it over here. That's my fin stock. I've basically stocked up on that months ago. So I'll use that for the fins. It'll be 1/4-inch ply. I thought about fiberglassing these tubes, but I kind of, it's nice. You get a nice finish, but it adds a lot of weight. And with more weight, there's a bigger parachute and bigger motors. It's tougher, but I don't know if it really lasts that much longer. You don't get as many chips and dents and dings when you fiberglass the tube. So I think for this one, I'm just going to keep it simple. I'm just going to just use the plain cardboard tubes. It's been done that way for years. I'm a level 1 certified, so it's not like I'm going to be flying J's and K motors and going to thousands and thousands of feet. I typically fly my rockets, you know, in the 1,500 to 2,500 foot altitude range and keep them close with dual deployment. So anyhow, so that's the roundup of kits or parts for or basically the kit roundup of parts for this thing. So I'm going to kind of shut it down here. Then we'll kind of put things away and we'll get started assembling and working on this thing, and I'll go through it step by step with you. So anybody can do this. It's well, I guess it is rocket science. Technically it is rocket science, but it's good to build something. It teaches lots of skills, patience, and all those kinds of things. Plus, just, you know, if you've got young people in your house, it's really good for them to build something, to make something. It's not, you know, and it's kind of cool too for them, you know, with Rock Sim, the young people, kids in grade school, even teenagers, you know, there's lots of opportunities with the American Rocketry Challenge with NAR and things like that, and the whole, STEM, engineering, design kind of stuff. But they get to see it, you know, if you get Rock Sim, you get to see it go from the computer screen. A lot of their life is on a computer screen, but it goes from the computer screen to actually something. Then you go out to the field and you fly it, and there's smoke and fire, and it's just fun. You're out in the sun. It's just a good time. It's a great way to kind of teach some of those skills, and you know, the kids can go, yes, I built that. You know, that was not a kit. I came up with the design. I did it. I built it. I bought the parts, and it's really a great feeling of accomplishment. So anyhow, OKTurbo is rambling. I'm going to turn it off here, and we'll come back and we'll start building a rocket.